When you think of a volcano, you probably picture this massive, fiery explosion, right? It's one of the most powerful spectacles on Earth. But what's really incredible is the power you don't see, the silent, immense force that builds for years, even centuries deep underground. It's a force strong enough to literally lift mountains. So the real question isn't just about the explosion, it's about the upward force they're building right now.
Okay, so let's just throw a number out there to set the stage. Over 300 megapascals. Now, on its own, that number probably doesn't mean a whole lot. But this is the kind of insane pressure we're talking about inside a magma chamber, miles beneath our feet, just relentlessly pushing up, up, up.
To really get a handle on what that means, think about the tire on your car. It's holding around 0.22 megapascals. The pressure inside a magma chamber, it can be over 1,000 times greater. We're not just talking about a little more pressure here. This is a completely different league of force, one that's capable of cracking and bending solid rock like it's nothing. So here's our game plan for this explainer. We're going to start with the planet's inner fire. Then we'll see how that creates a massive pressure cooker underground. We'll talk about the secret ingredient, gas, that really makes things go boom. Then we'll look at the two main ways volcanoes can erupt, and finally, we'll get into why this staggering power actually matters to us.
All right, let's dive right in at the source of all this energy, the planet's inner fire, where this whole process kicks off deep inside the Earth.
Everything, and I mean everything, starts with magma. And I want you to get the image of just, liquid rock out of your head. It's so much more complex. It's this superheated, high-pressure cocktail of molten stuff, solid crystals, and a ton of dissolved gas. This mixture gathers in these huge underground reservoirs called magma chambers, which can be absolutely massive. This is the fuel for the whole engine.
Okay, so we've got the fuel. Now, how do these chambers turn into these massive geologic pressure cookers? This is where the force really starts to build, setting the stage for what's to come. This quote just nails it. Long before any lava or ash ever sees the light of day, the pressure is already doing some serious work. We are talking about a force so staggering, it's physically lifting billions of tons of rock, making the ground itself swell up like it's taking a deep breath.
And we saw this happen in real time right before our eyes at Mount St. Helens. Before that famous eruption, a massive bulge started growing on its north side. And get this, it was expanding at a rate of 1.5 meters, that's about 5 feet, every single day. That bulge was a direct, visible measurement of the unbelievable force pushing up from inside.
But what makes this pressure so explosive? I mean, it's not just the molten rock. There is a secret ingredient in this whole mix that really cranks the power up to 11.
Honestly, the best way to wrap your head around this is to think about a soda bottle you just shook up. Deep underground, under all that pressure, gases like water and carbon dioxide are totally dissolved in the magma. You can't even see them. But as that magma starts moving up, the pressure drops. And suddenly, just like when you twist the cap off that soda, all those gases come rushing out of the liquid. They form bubbles that expand incredibly fast, and it's that rapid expansion that literally launches the magma skyward.
Now, this combination of pressure and gas doesn't always have the same result. It can unleash its power in two totally different ways. You can get a violent, fiery blast or a steady, flowing river, and it all comes down to the magma itself. The deciding factor is something called viscosity, which is basically just a fancy word for how thick and sticky the magma is. If the magma is really thick, like honey, it traps all those expanding gas bubbles. The pressure builds and builds and builds until it just can't hold it anymore, and boom, you get a catastrophic explosion like Mount Pinatubo. But if the magma is thin and runny, more like water, the gas can escape easily, and you get those amazing, mesmerizing rivers of lava we see in Hawaii.
And the scale of these explosive eruptions, it's just hard to comprehend. Take a look at Mount St. Helens. It threw out about 1 cubic kilometer of rock and ash. Pinatubo was much bigger, around 5. But a super eruption like Toba, we're talking nearly 3,000 cubic kilometers. That's not just a bigger eruption, that's a planet-altering event. The upward force needed to do that is almost beyond imagination. So this is all fascinating, right? But why should we care about this incredible power? Well, it's not just scientific curiosity. This is about safety, prediction, and really grasping what a dynamic planet we live on.
Let's look at the Yellowstone supervolcano. During times when the magma chamber is stirring, scientists have measured the actual ground rising and falling by several centimeters a year.
Now, I know what you're thinking. A few centimeters, who cares? But wait,
You have to remember what is being lifted. That minor movement is being caused by a force strong enough to raise the entire weight of the Earth's crust sitting on top of it. We're talking billions and billions of tons of rock. It's a direct, measurable symptom of the incredible pressure cooker simmering just a few miles below.
And this is the really cool part. We're not just guessing anymore. We can actually watch these forces build in near real time. We use this amazing toolkit, GPS satellites that measure the ground swelling by millimeters, tilt meters, sensors that feel the tiniest tremors, and even instruments that can sniff the air for volcanic gases. It's like we're giving the volcano a checkup, and that lets us forecast what it might do next and ultimately save lives. So in the end, this immense upward force is one of the fundamental processes of our planet. It's destructive, for sure, but it's also creative, constantly reminding us that the ground we stand on is anything but static. It is a living, breathing system. And that question there is the perfect way to leave it. Earth's greatest energies come from within. Are we listening to what they're telling us? You know, with all this technology, I think the answer is, for the first time in human history, yeah, we're finally starting to listen.